Hi everyone, and welcome to this first video in a series where we will explore generative AI, keeping things simple, practical, and hands-on. I've always believed the best way to learn is by doing. So a few months ago, I started a YouTube channel as a personal challenge to see if I could automate every part of video creation using only open source, self-hosted tools. Think about it: scripting, generating visuals, voice covers, editing, and even publishing, all powered by AI. And in this series, I will share everything I've learned step by step. Whether you are new to AI or already tinkering with it, my goal is to make this accessible, no hype, just real-world testing and problem solving. Today, we will start with the basics. What is generative AI? How does it actually work? And why does it matter? Let's get into it. Let's begin by understanding what generative AI is. Generative AI is a type of artificial intelligence designed to create new content. First, it's powered by neural networks. These are advanced algorithms like GPT or diffusion models that are inspired by how the human brain works. These models are trained on vast amount of data to learn patterns and structures. Generative AI generates new data from scratch. It doesn't just copy examples from its training data. Instead, it predicts and combines the patterns it has learned to produce original outputs, such as text, images, or videos. Finally, generative AI improves with training. The more high-quality data it's exposed to, the better it gets at mimicking human-like creativity. Now let's explore some types of AI models, starting with text generation. Imagine giving the AI prompt like, write a short story about a cat. The AI processes this input using a neural network, which analyzes patterns and structures learned from its training data. The result? It generates a unique story. This is how text-to-text models work. They create anything from short stories to technical explanations, depending on the input. Next, we have image generation. Here, the AI works with a different kind of neural network designed to create visuals. Let's take a simple input like a cat in a forest. The neural network processes this input, combining patterns it has learned about cats and forests. The output is a unique image that matches the description, as you can see here. This capability is part of what makes generative AI so versatile. It can create highly detailed original images just from text. Moving on to video generation. Using similar principles to image generation, video models take things further by creating animations or videos. These models combine multiple images and apply temporal consistency to produce smooth transitions, resulting in a short clip or a video. Here is an example, starting with the still image we just created and generating a short video showing movement. This is still an evolving area, but it's exciting to see how quickly AI is advancing in generating dynamic content. Beyond text, images, and videos, there are many other types of AI models. For instance, text-to-speech models can turn written text into natural-sounding speech, allowing for control over voice, tone, or even emotion. Then we have transcription models, which convert spoken audio into text. These are useful for tasks like creating captions or transcribing meetings. Finally, there are multimodal models like GPT or Gemini, which can work across multiple formats, combining text, images, and even videos. Now let's take a look behind the scenes at how an AI model processes input. The first step is tokenization, where the user input, such as create a short story about a cat, is converted into a format the AI model can understand. Being statistical models, AI work better with numbers rather than text. So the tokenizer breaks the input into smaller pieces called tokens. Each token is then assigned a unique number called the token index. For example, the create a short story about a cat might be split into 8 tokens corresponding to 32 characters in total. It's worth noting that different providers may have different ways of splitting the input into tokens, but the idea is exactly the same. The same process applies to the model's output. The short story generated from our example input might consist of 67 tokens, translating to 311 characters. It is important to note that many inference providers charge for their services based on the number of tokens used. These providers often apply different rates for input tokens versus output tokens. After tokenization, the next step is creating embeddings. Embeddings transform each token into a dense numerical vector. These vectors exist in a high-dimensional space and represent both the semantic meaning and grammatical structure of the token. Words with similar meaning will land closer to each other in this space. This allows the model to capture complex relationships, such as synonyms, genders, or context between words. Embeddings act as the bridge between the discrete tokens and the AI model's deeper understanding of the input. The next piece we will cover here is attention. This mechanism is what makes the AI model understand the context of the input, not just the individual words. Attention allows the model to evaluate the importance of each token in the sentence. For example, in the query, create a short story about a cat, the model identifies relationships between the tokens, such as the subject cat and the action create and the output format story. This is what enables the model to focus on what matters most in the input to ensure accurate and context-aware outputs. Once the embeddings and attention mechanisms have processed the input, the model begins generating the response through a process called sampling. In our example, the user prompt, create a short story about a cat, the model analyzes the context and assigns probability to all possible first words. Usually, the word with the highest probability, in this case n, is selected as the first word. This probabilistic approach ensures the generated text is coherent and contextually relevant while leaving room for variation. After selecting the first word, the model continues building the sentence iteratively. With the user input and with the first word chosen, the model evaluates the probabilities of the next word. The model might again choose the word with the highest probability, extending the output sentence. This process repeats with the model updating the context at each step to predict and select the next most relevant word. By combining probabilities and context, the model generates sentences that are both coherent and context-aware. As the model builds the sentence, it tries to balance creativity and predictability to produce engaging yet original text. In this example, and although the next possible word, small, has the highest probability, the model may select the word quiet instead, due to adjustments by a parameter called temperature. Temperature is a parameter that controls the randomness in text generation by scaling the probabilities of word selection. With the lower temperature, the model focuses on high probability words, generating deterministic and concise outputs. This setting is ideal for technical or factual tasks. With a higher temperature, the model allows for the selection of less probable words, encouraging diversity and creativity in the output. This is especially useful for storytelling or creative writing. While temperature is essential, there are so many other parameters that significantly influence the model's text generation. We'll explore some of these parameters in detail in a dedicated video later in our series. Now let's take a closer look at some of the key characteristics of AI models. The first characteristic is the number of parameters. This refers to the total count of weights and biases in a model, essentially determining the model's capacity to learn. Models with more parameters can capture complex patterns, resulting in a better accuracy and more sophisticated outputs. However, this increased capability requires larger datasets for training, higher computational power for both training and inference, and greater memory and storage requirements. The second key characteristic is the context window. The context window represents the maximum number of tokens the model can process at once. A larger context window enables the model to handle longer documents, maintaining coherence in extended conversations, and follow complex instructions. On the flip side, this increases memory requirement drastically. The third characteristic we will cover is quantization. Quantization involves reducing the precision of a model's parameters. For example, converting from a 32-bit floating point to 8-bit integers. This optimization reduces memory usage and speed up inference, making models more suitable for consumer hardware. However, there is a trade-off, a slight decrease in accuracy during the quantization errors. But in many cases, this trade-off is worth it for the efficiency gains. By understanding these characteristics, we can make informed decisions about selecting the right model for our specific needs, balancing performance, cost, and resource requirements. Model capability is not the only important factor to get good results. There are many strategies to improve the LLM results. The simplest way is by improving the prompts we provide. A powerful model with poorly constructed prompts or prompts lacking context will often produce inaccurate or unsatisfactory outputs. Providing the model with sufficient context and using well-constructed prompts, also known as prompt engineering, can enhance the quality of the generated responses without any additional cost. However, there are situations where even the best prompts won't suffice. For example, when dealing with specific domain data, internal company documents that the model didn't have access to during his training, or even information that occurred after the model's training date. In such cases, we can turn to two key techniques. Retrieval augmented generation is a powerful technique that enhances the capabilities of the large language models by giving them access to up-to-date domain-specific information. At its core, RAG works by adding a retrieval step to the LLM's generation process. When a user poses a query, the RAG system first retrieves the relevant information from a designated knowledge base. This retrieved information is then provided to the LLM as context, allowing it to generate more accurate, informed, and contextually relevant response. The last technique is fine-tuning. This involves additional training of the model on specialized datasets to make it gain expertise in a particular domain or task. While this approach provides better results, it requires more computational resources and higher costs. We can, of course, combine these strategies to unlock the full potential of LLMs for a wider range of applications. And this concludes this section about how LLMs generate text and their characteristics. Now let's talk about images. The process is very similar to how artist works. Imagine the AI starts with a blank canvas full of random noise, like static on an old TV. This is its rough draft. Then, step by step, it refines that noise guided by the user prompt. Think of it like a sculptor shaping a clay. With each step, it removes what doesn't belong and sharpens the details. The key here is something called diffusion process, where the AI iteratively cleans up the noise until the image emerges. We can control how strictly it follows our prompt using a parameter called CFG. A high guidance scale means it sticks closely to our request, while a lower value lets it get more creative. Very similar to temperature for text generation. Now, what if we gave AI not just the ability to create text and images, but to act on its own? That's where AI agents come in. While chatbots like ChatGPT are great at conversation, AI agents take this further. They are like giving the AI models a brain and hands. Let us break it down how they work. First, they reason. They analyze information to make smart decisions. So if we ask them to plan an ideal summer vacation to Paris, they won't just list options. They will consider our budget, preferred dates, and past trips to recommend the best choice. Next, they plan. They break complex tasks into steps. For our Paris trip, the agent might create this plan. First, find a flight with the best value. Second, book a hotel near our preferred attractions, all without us needing to oversee each step. And so they can act. If we need that flight booked, they will search airline websites, compare prices, and secure our tickets, by maybe using tools like our calendar to check availability. For more complex tasks, they can collaborate with each other to handle things like visa requirements or local transportation requirements, etc., etc. And then finally, and crucially, memory. They can remember our preferences. If we always choose window seats, they shall factor that in next time. So while chatbots can suggest vacation ideas, an AI agent can actually plan and book our entire trip. That's the power of AI agents. They doesn't just think, they take actions. To wrap up today's session, we have explored how AI can generate text, create stunning images, and even act autonomously through intelligent agents. When we combine these AI capabilities with smart automation, we unlock systems that can handle complex workflows from start to finish without constant human intervention. In our upcoming video, we will build this together, step by step. First, we will prepare our environment by setting up all the necessary tools. Then we will dive into self-hosting text generation models using open source solutions and learn how to integrate them with our automation engine. And from there, we'll expand to local image generation, audio synthesis, and video creation. Finally, we'll put all this together in a system that automatically publishes finished videos to social media. So if you are excited to build this with me, make sure to subscribe so you don't miss any part of this journey. Thanks for watching, and I can't wait to see you in our next video.